So the thing is, in this AI era, right, it's not enough just to write some code. So basically, it's not enough to be a developer, software developer. Okay, you have to think like a software architect. If you are just writing code, if you're just a simple developer who is heavily relying upon the senior developer who will be giving you a simple file and who will be asking you just to write a function, okay, then you will get replaced by AI very easily. So what do you have to do to stay relevant? You have to understand about software architecture. You have to understand how to structure the entire application. But the sad part is many of the developers, mostly the junior developers, does not even know like what do you mean by software architecture, right? What's the difference between software development and software architecture? So my target with this video will be to basically explain software architecture, and whenever I explain something, I explain from the why. Okay, so we'll be coming from the history. Why did we need software architecture in the first place? So if you stick till the end of this video, I can guarantee you will get a clear cut idea about software architecture, and you will get a path like in this AI era. If you want to stay relevant, what are the skill you have to master? All right, let's get started. All right, so let's start from the very beginning, right? So around, I'm talking about around 1950s, 1960s, right? And around this time, hardwares were super expensive, right? And you didn't have any sort of this fancy programming language back then as well. And whatever programs or software you were having at that time, those were very small. Okay, like for comparison, if I take any modern day programming language, you can fit the entire program in a single file, maybe within 200 lines. Okay, and mostly softwares were used in mathematical operation, military purposes, and there were different sort of like space program that was happening around that time, right? This 1950s, 1960, and mostly softwares and programs or computers were being used in these purposes only. If I give you a simple example of a program, so this is a Motorola program. I don't even know like what is this. Like this is maybe assembly language. So this is an entire program, right? And for example, let's say if I give you a military example, so they will be calculating like at which angle you have to fire the bullet. Okay, so you can have a program, and that program you can give certain input. Okay, you can give some certain variables, and it will do some calculation, and it will give you the output. It's just a fancy calculator. All right, so this was the very starting era of software. And as you can see, like as softwares are very small in size, you didn't need a lot of organization in a single page. Like they used to have punch card as well, if you're familiar with that. And they used to physically punch card, right? And they used to fit that in a machine, and that was the basically the source code. And also around that time, there weren't any kind of group project, right? So for a particular program, max to max two people were working, right, for a solution. So you didn't need a system to manage those, and they're not producing source code separately. So this is the 1950 1960 era. Software was just a script, and you didn't need a system to organize them. Now around 1990 to 1970, things were not that good, right? So in the previous era, basically the government projects were using programs or softwares, right? And those were very small. But in this era, business had started, like many of the business was introducing computing in their business management as well. And what happened is software started growing, right? You could not just have a single script for a program, right? You had to manage multiple script. And in the previous era, you were working with like for a single script, a single or two developers might be working on that project, right? And developer size, like team size got increased as well. Now 50 to 100 developers are working on a program. But the problem was in this era, till late 1970, there was no organizational method like you should write your code in this way. Like if you know about Fortran programming language, right? So there's a thing called go to statement or everywhere, like uncontrolled, like there is no concept of function even. Okay, so yeah, this was an horrible state for software development. And actually the late 1970s is called software crisis era. Okay, so there were demand for software, but the know-how we had at that time, we didn't have enough knowledge, like how to write and maintain and change according to the business requirement, how to change those software. We didn't know that. Okay, so this period was like very much problematic. All right, next comes this era, 1970 to 1980, right? So this is called the structured programming era. At the beginning of 1970, there's a guy called Dennis Ritchie. If you know this guy, right? He's the inventor of C programming language and the Unix operating system. So basically, Unix operating system is Linux, right? So Unix was kind of expensive, and Linus Torvald, you know him, creator of Linux, right? He needed an operating system, and he just entirely copied Unix. Okay, so Unix is the foundation, and this guy with couple of other guys in Bell Labs, they have invented Unix. Okay, and to write Unix, they needed a complicated, like there is, you can see, right, you are writing an operating system, so you need a robust programming language and robust architecture for that, right? So these people has invented all those fancy thing that you know nowadays, right? So things like if statement was there inside Fortran as well, but yeah, for loop, the recent time for loop that you know, right, that was invented in this era in 1970 to 1980, right? And like there's a thing called procedural programming, right? If you are very new to programming, if you're just starting out, or I see many experienced developer also, whatever paradigm they are following, they are actually following this structured programming era, right? So people were using functions, procedural call, right? So let's say inside an organization, you have to calculate the payroll. So first you find out the employee details, maybe. Then you find out what's the CTC for that employee. Then you calculate the tax. Then you calculate the payroll. So this is the process you are following step by steps, right? So this is called a procedural flow, right? So this type of procedural programming was invented around this time. So that was the structured programming era. Now, very soon, people understood that structured programming or procedural program is not enough. So the main problem was you cannot think through a problem. Like if I ask you to design a very complicated software from scratch, right? And you start designing the software with this procedural programming mindset, right? So it will be very difficult very soon. Okay. So maybe you have experience with a single or two script. In that situation, it's fine. If you're writing a simple function, single behavior, for those kind of things, it's fine. Step by step process you follow, that's okay, right? But it was not enough. Around 1980, 1990, softwares are getting crazily big, right? Graphical user interface are getting introduced, and almost all the enterprises were adopting different kind of softwares, right? So for that reason, around 1980, 1990, in this era, they have introduced a new paradigm. And I believe you already know this term, right? Object-oriented programming. So this was called the object-oriented programming era. And there's another legend named Alan Kay, right? He's the, you can call him the pioneer of graphical user interface, right? So this device, right? You can point to somewhere inside your computer and click and it works, right? So he has a hell lot of contribution on this graphical user interface, right? So he has first coined this term, object-oriented programming, and his idea was if we can compare the different software component with real world objects, then it will be easier to think through. For example, let's say you are designing a software for car radiator, maybe, right? Now radiator can have different properties, like what's the temperature right now, what's the rotation and speed of the fan, is it on or off, and it can have different behavior, right? So recharge the coolant, maybe, or stop the fan, start the fan. Those will be the behavior of this radiator, right? So if you are designing different software for car, and there's a component called radiator, and if you design the radiator in an object and you give it some property, give it some behavior, then you will be able to think through the problem, right? So in this situation, I want to change this property, I want to call this method to change this behavior. Those sort of things you can design very easily through object-oriented programming, right? So that's why object-oriented programming was invented, basically to help you with the software architecture. Okay, so that was the object oriented era. Then came the internet. So, whatever we have discussed so far, your source code was running in a single computer, in a single processor, right? So, when we did have internet, so around 1990, 2000, internet was like getting popularity, right? So, around that time, that was not the case. Like multiple computers were connected, and one computer is requesting data from the another computer. That computer is serving the data, right? That famous client server architecture, if you know about that. Now you have to deal with the network failure, like in case of network failure, how to deal with that. You have to deploy your software in the server, right? You have to run your code in the client as well, right? And there's a thing called distributed architecture was getting into the place. So your data is living somewhere, a separate service is living in another computer, your web server is sitting in some computer, right? Your client is talking to the web service talking to some other service, maybe database is sitting somewhere, right? So this is called distributed architecture. Now you had to write your source code in a fashion that you support this network activity, right? So this was the internet era. And if you're familiar with the MVC architecture, right, model view controller, so this was basically introduced in this era. So yeah, that was the internet era. Now after 2000, internet gradually kind of exploded, right? You got your social networking sites like Facebook, Orkut, Twitter, and websites like Google, Amazon, eBay got popularity, right? And also third world countries, people also have started using internet. So till this point, whatever softwares you were writing, those softwares were having, let's say, user base of in the order of, let's say, 1,000 or max to max 10,000. Okay, but after 2000, you were writing a software that will be running in a server, and that server is handling a user base of million, in the scale of million, right? So you had to think differently. Now you had to design your system a little bit differently. Things like cloud microservices are getting introduced at this era, right? And scale was everything, right? So things like Kubernetes, Docker, messaging service, different types of messaging service, queue, those kind of things were getting introduced around this time, right? And you had to keep an eye on the costing part as well, right? And you had to divide your services. You have to individually scale those services, scale up, scale down, and you have to obey the service boundary. Those kind of many fancy stuff got introduced around this time, just to scale up your system, right? So this is the basically the cloud and microservices era, you can say. And now we are entering into a very interesting era, that is AI is generating code for us, right? But one thing you have to keep in mind, that whatever software architecture we have been discussing so far, that is not going to be replaced. And if you do not guide the AI properly, right, it can generate code from by following the architecture from any era, right? And it will mix multiple architecture together as well, right? And that's completely up to the model, and that will be very problematic. So all I'm saying, if you do not understand the architecture, then you will mix things up, right? And if you are mixing multiple architecture, if the project grows a tiny bit even, it won't make any sense. You will not be able to continue. So after writing couple of lines, or let's say you generate the UI, you generate couple of pages, you generate couple of handlers, right? So after that, it will give you a feel like, let's start over. I did something, I messed up somewhere, let's start over. So nowadays, what I see on pattern is like whoever is doing vibe coding without understanding these things, right? They will be like creating a small application, right? So AI is very good at uh, writing code, how we were writing code in this era, right, at the beginning. So you will be having a small application, that application will be having a single job, right? So you ask the AI to write that application, AI will give you the UI code, it will give you the API handler, everything, right? But once the program is getting complicated, once you are stepping into like more complicated software, that in that situation, if you do not understand the architecture, AI cannot help you. That's for sure. And you know that if you are doing a lot of vibe coding nowadays, if you do not understand the architecture properly, you will get a feel that okay, I did something wrong, let's start over. So that feeling of let's start over is the basically the signal that you are missing the architecture, you don't understand the architecture, right? And on a very interesting part is I was watching a YouTube video that other day. I guess the video title was software crisis in this AI era, right? And he was mentioning on a very cool thing that prior to this AI era also, right, you had all of your code inside all this open source project, right? Inside GitHub you had a lot of free and open source code that you can just copy and paste into your project, right? And you could pick up code from Stack Overflow as well. But you didn't do that. Why didn't you do that? Because you didn't understand the architecture, right? You didn't understand, like, from where you were copying the code, you didn't understand that code base. For that reason you didn't able to use that code in your code base, basically, right? Now with the AI, what AI is doing is AI just copy pasting the code from that code base, and it is adding some sort of context. But if you do not guide the AI, then it can go anywhere, right? And if you like if you are not a system designer, and if you do not have your entire system in mind, right, you won't be able to think through the next step, right? So if someone is asking you to add a new feature, and your code base has, let's say, 500 files, every time you cannot feed 500 files to the AI, and it will understand the context, and then it will answer your question. It's not possible. But how you can use the AI properly? You can set up a project which has a clear cut architecture, and you understand that architecture. Then for particular functionality, you can generate code. So let's say you are following a domain driven design, right? And you are having an infrastructure layer, and inside that you need to create a database. Let's say you are connecting to an SQL database, right? You are having a single file, and on that file you can just ask the AI that in the structured fashion you write some procedural code there, right? And I'll be just using those in my services. Those kind of things AI is very good. Okay, yeah, AI can, like, in the previous days we would a senior developer would tell some junior developer that just this is the abstraction layer, and just implement this abstraction layer. Like, they will give you the abstract class or the interface, and you have to, like, implement that interface, right? So right now, nowadays, instead of asking the junior developer, you can ask AI that this is my interface, just write a concrete implementation from this interface. Okay. So, but you have to understand what is an interface, what is a concrete implementation, how you're abstracting things out. Okay, and that is coming from the um, architecture part. Okay, so yeah, if you do not understand architecture, then AI won't be able to help you, and you will just get that feeling that something is wrong, and I need to start over. And you will be like, if I start over in the next iteration, I will make everything perfect. Okay, but that will never happen, trust me. I have been using AI to write code for about 2.5 years now, right? And at the beginning, I was having the same feeling that AI will replace me, and yeah, I will be able to write a lot of code, I will be building a lot of projects with AI. But that didn't happen. So learn the architecture. And my entire goal with this video was to basically show you how, like, from the history, right, how we have came up with till this point, like cloud and microservice architecture, and all these things are just helping us to authoring code properly, right? Where should you put the class, where should you put your interface, how should you call different method, where you should not call different method, how should you declare variable, where you cannot declare a variable, how can you access the infrastructure layer, where should you put your user interface code, those kind of things this software architecture is teaching you, right? So yeah, I'm learning a lot about software architecture nowadays, and I have a keen interest on cloud. Like, if you follow my channel, you already know that, right? And the thing is, in this era, if you want to learn about software architecture, you cannot avoid cloud, right? So, yeah, that's why I'm a very big fan of AWS. And yeah, if you want to learn about this stuff, you can follow this channel. I'm planning to create a lot of videos around software architecture. Thanks.